In this first lesson, we're going to examine sets. A set of things is a group of objects, obviously, and we're going to examine some of the ideas that how we can organize them, how we can look at some notation, and just a basic introduction of some ideas we're going to use throughout the rest of this course. So as I was saying, a set is a collection of numbers or objects. Okay, so for example, the set of vowels, we use the capital V for vowels. And in ellipsis brackets, these are these fancy brackets here, all the vowels are A, E, I, O, and U. Okay. Some people might say, oh, why is the letter Y not in there? I've defined the vowels as just these 5 things. These 5 things are each called elements. An element is a member of a set. Okay. We use sort of like a fancy looking E for element. So for example, I is an element of V, so I, EV. And we put a slash through it, this one here, if it's not an element. So the letter M is not a vowel, so M is not an element of V. Kind of a big idea here, the null set, a set that has no elements. An empty set has brackets, have nothing in them, or we use a 0. Okay, so we said we have the numbers 1 through 10, let's say. How many of those things have 3 digits in them? Well, 3 digits, there's nothing between 1 and 10 that's got 3 digits, so that set would be empty. There's nothing in there. Sets can contain subsets. That would be a smaller group taken from the larger group. And we use this sort of sideways, this C with an equal sign underneath it. And we read that as P is a subset of Q, so the order is important. Okay. If something is not a subset, again, we're back to the dash or a slash through the line. So if we had the set A, and it's made up of 0, 1, 2, 3, 4, 5, and B is made up of the set 2 and 4, well, since all of B is taken from A, we could say that B is a subset of A. We could not say that A is a subset of B, however, because all the things that are in A are not in B. And back to the idea of the null set, the empty set, it can always be considered a subset. I could say I have a subset C. It's the null set. There's nothing in it. I took it from A. Well, what I'm basically saying is I took nothing from that group. Okay, so a little example here. Can you try writing these and using set notation? So our objective here is to take words, turn them into symbols. So pause the video, try it, see if you can figure them out. And if not, then play it again. So 3 is not a subset of G. 4 is an element, so it's a fancy E, of the digits 0 to 5. And A and B are a subset of A, B, C, D, E. So A and B are a set. I'm going to put them in ellipsis brackets. And it's a subset of A, B, C, D, E. Okay. If we just a common idea we can talk about is the number system. So the real number system, what we've been working with for years and years and years, is made up of sets and subsets. So the natural numbers, the things you can count on your fingers, we call that usually the letter N for our symbol, is made up of 0, 1, 2, 3, 4, 5, and on forever. Positive whole numbers, things you can count on your fingers if you had enough. We have integers. Those are all the positives and negatives whole numbers. You can't necessarily count them on your fingers. They're slightly bigger than that because you have those negatives. Okay, we call that the letter Z for integers. It's this one. Okay, we have rational numbers. Rational numbers are anything that can be written as a fraction. Okay, that's made up of a whole number on the top and a whole number on the bottom. So for instance, 2/3. Okay, and those anything, lots and lots of things can be written as fractions, even if you don't think of it that way. The number 10 is a rational number because really it's 10 over 1. Okay? This would include anything with a repeating decimal like 1/3, 0.333333 forever and ever and ever. Those are rational things. Okay? There are some things that cannot be written as fractions, however. We call those things irrational. We use Q with a little dash here. Q naught, not Q. Okay, so anything that can't be written as a fraction. So for example, pi root 2. Somebody might think well, you can write pi over 1, but remember this has to be an integer, and pi is not an integer, it's a decimal itself. Okay? Well, if you take those ideas, these are actually subsets. Natural numbers are a smaller group of integers. And integers can all be written as fractions. So those are a smaller group of rational numbers. So we actually take them and diagram it out. We have the natural numbers on the inside. It's a small group within integers, which is a small group within rational numbers. And then we have outside that irrational numbers. They're a separate group that are not part of the first three things. And just an idea of where we can actually use these set ideas. Okay, so we have a little example here again. Pause the video, try it yourself, see if you can figure what's going on here. I want to complete a table by placing a tick in the appropriate box if the number is part of the set. So, can I write 1.3 as a natural number? Can I count down my fingers? No. Is it an integer? No, it has a decimal involved. Can I write it as a fraction? Remember what Q is, that's a fraction. Well, yes, I can. I can write this as 13 over 10. So it's a fraction. Pi. Can I count on my fingers? No. Integer? No. Can I write it as a fraction? No. So no ticks. -6. Is it something on my fingers? No, but it definitely is an integer. I can definitely write it as a fraction. -6 over 1. Give you a hint here. Once you make a check mark, the rest of the things below it should have check marks because they're subsets. 6 over 3, a better way of saying that might be the number 2. I can count that on my fingers, so it gets a check mark. Because I put one check mark in, I should have 2, 3. Okay, and then root 2 over 4. Well, root 2 itself is a big decimal. Okay, a never-ending decimal, which means I can't count it. It's not an integer. It's not even a rational number because the top number is itself a decimal. Okay, we've written it nicely as root 2, but since it's a decimal, I can't put anything down here. Okay, some more big ideas for us. Some ones we're going to use a lot in our first unit. Our first unit is about probability, and we want to talk about some symbols we're going to come across repeatedly. So the first one's a union. It's the set of items that are contained in one set or the other or both. We use the symbol U for union. And we'll do some examples in just a second here. The sort of counterpoint to that is something called an intersection. It's a set of items that are common to both. And we use this symbol here, it looks like an upside down U. I like to think of it as the word intersection. That's why it comes from the N. Or, if you will, even better, the word and. It's the N in the middle, and. In other words, it has to be in one set, and it has to be in the other set. It has to show up in both. Sometimes you're not going to have any common things. If there's no common elements, we call that disjoint. And we get the empty set, the null set. There's nothing in common. And so let's take a look at some examples here. So example number 1. Okay, I want to find the intersection and the union based on set A and set B. So we'll do the intersection first. Now remember my idea of this intersection means and. What shows up in A and shows up in B? What things show up in both? Well, I look at these sets and I see the number 3 and the number 3 and 4 and 4. So the end, the intersection is 3 and 4. Now the union, on the other hand, means A, and the way I like to think of union is the word or. It could be in one, or the other, or both. So what's in A or B? Well, the number 1 shows up there, and 2, and 3, and 4, and 5, and 6. In other words, the union, the or, is a list of all of the items that show up in either A or B. Okay, let's try the next one. You're going to do the same things. Try pausing it this time, see if you can do this one. What shows up in A and B? A is all the consonants, B is all the vowels, including Y. So what shows up in both of those things? Well, I guess it sort of depends on your definition of the letter Y, if you will. If we're saying that Y is a vowel, it's not a consonant then. That means there's nothing. It's the null set. There's nothing in common here. Right? If I do A or B, however, I've got all the consonants and all the vowels. In other words, I got all the letters. So I'm going to call this my alphabet. Okay, it's a list of all the things that show up. Okay, so there's some basic ideas. We'll come back to those again in a second. We've got some more ideas here. The number of elements in a set. If I want to know how many things are in there, how many things are in the set of vowels, for instance, well, I'm going to use the symbol n and then in brackets whatever set I'm talking about. So if we're doing vowels, the number of vowels was 5. Okay, that's how I know I'm making a number, an answer, as opposed to a list of things. Okay. Sets can be finite. In other words, you can count them, the set of letters. There's 26 of them. Or they could be infinite. They keep on going and going forever and ever and ever. The set of positive integers. Think of the biggest number you can think of. You can always get bigger than that. There's always one more than that. Because an infinite set cannot be counted, we say that the number of things in that set is infinite. That's a symbol for infinite. Okay. Okay, last two big ideas. A universal set. This is basically our starting point. These are all the things that we're talking about. All the possible values. So if we're talking about our class, we'd say, who are the people in our class? It would include everybody. Me, all the students, anybody who's in the room. From that, I might take some sets. I might take, here's the boys, here's the girls, here's the 16-year-olds, here's the 17-year-olds, here's the 18-year-olds, here's the students, here's the teachers. Okay, but our universal sets are our starting point. We usually use the letter U to signify that. Now be careful, there's U's, and then there's the union, right? They're kind of like the same, so you got to look at your context to figure out what you're talking about. If we were talking about letters, the universal set would be the alphabet. From that, we could take vowels or consonants or things like that. Once you've taken a set out of the universal set, you're left with a complement set. Now, what that means is those are all the items contained in the universal set, but not present in a subset. So for instance, if I had the universal set of 1, 2, 3, 4, 5, 6, that was my starting point, and I took out 2, 4, and 6, the even numbers, the things I'm left with would be the odd numbers. And we show a complement set by putting a little dash next to the letter of the initial set. So this was A, so I have A naught. That's what we call that, A naught, or if you will, not A. Okay. Together, A and not A should make up your universal set. There shouldn't be anything missing from those two things, because those are the opposites of one another. Okay, last page. Just some reminders from functions kind of things, some things we're familiar with, just so we can use that somewhere else. We call this set building notation. Okay, so this is a big, huge statement in math. We want to turn it into English and be able to read it. What does it mean? So we have the set A, capital letter. Letter A is made up of values. Those values belong to, that's what that E means, Z. If you remember, Z stands for integers. Okay, so we're going to come across things like natural numbers, or Z, or rational, or real. Those are different things we can come across. And which values do we want to include? We want to include 0, including 0, it's equal to 0, all the way up to 20. But not including 20 because there's no equal sign right there. There's just a less than sign. So from 0 to 20, including 0, but not 20. Okay? That's our set. It tells us a whole bunch of things. I got the numbers from 0 to 19, and they have to be whole numbers without writing all that out in words. I can do it with notation. We're going to take that idea and try and do this question. Okay? So I've got a universal set. It's made up of integers, specifically the ones from -4 to +4. So if I wanted to, I could write that out. -4, -3, -2, -1, 0, 1, 2, 3, and 4. I'm not saying you have to, I'm just saying you can if that helps you. From that universal set, I've taken S. S is also made of integers, but it's only from -1 to 1. So S is -1, 0, and 1. And then we have a second set, T, again made of integers from 0 to 2. I'll write that one over here. 0, 1, and 2. Okay, there's our information in our question. We started with U, the big set. We took some subsets out of there, S and T. What do they want us to do here? Well, let's look at the first question there. Kind of nice. It says, make a list of the elements of S. Well, I know what those are. I already wrote them out. -1, 0, and 1. Make a list of T not. So things that are not in T. But remember, we're going back to the universal set, our starting point. So if T is made up of 0, 1, and 2, it doesn't include -4, -3, -2, -1. It does have 0, 1, and 2, but it doesn't have 3 or 4. Those are the things not in T, but were part of the question, part of the universal set. Okay, part C, the intersection, S and T. What shows up in both of those? Well, I see the number of zeros in both, and 1. Okay. Part D, S and T naught. So I'm going to look at S. I'll highlight these things here. So I'm going to look at S, this one, and T naught. Now T naught's right here. We did that one. What shows up in both of those two things? The only thing I see that shows up in both is the number -1. And it has to be in both because that's what intersection means. Okay, how about the next one? S naught and T. Now, I don't have a list of S naught, but I could pretty quickly write it out. S naught is the opposite of S. So I've got -4, -3. It helps sometimes to write them out just so you can see the parts you're dealing with. S included -1, 0, and 1. So what else was left? There's still a 2, a 3, and a 4. Okay, I'm looking for things that are, what am I asking for? S naught, that's this one, and T, that's this one. What shows up in both of those things? Looks to me like just the number 2. I don't see anything else that doesn't show up in both of those. Okay, let's try F. F is S or T. So anything that's an S or anything in a T. So I see a -1. I see a 0's in both. I see a 1 also in both. And I see a 2. As long as it shows up somewhere in S or T, it gets into my list. Okay, last one. S and T naught in brackets. So this is the complement, the opposite of just S and T, which we've seen already. That's question letter C. So I need the opposite to part C. C was 0 and 1. So the opposite to that would be I need a -4, a -3, a -2, a -1, not 0 or 1 because they're in S and T. And I need a 2, a 3, and a 4. Okay, there's some introductory things in set notation, how to talk about sets, how to use some symbols with sets, and some terminology, unions, intersections, complements, and universal. Okay, the homework's the handout. Give it a try. The answers on the website. You can check things out. If you're stuck, come see me, and then we'll go from there.